All right, chapter 7, section 3. Like I said, what it has to deal with is transport across the cell membrane. Okay, there are two types of transport that get used or that are talked about on your SOL test. The first one is passive transport. Sorry. Biggest thing to remember about passive transport is that it requires no energy. Okay? There's no energy required in passive transport. What it does is it moves from high concentration to an area of low concentration. Okay, and this is kind of what it means. Say, for example, that's our cell membrane. Okay, so this thing right here is the cell membrane. We can say this is inside of the cell, and over here is the outside of the cell. So if we're moving to high and low, the way to think about this is, say we got something up here, 3 little tennis balls or whatever, and we need to get them out of the cell or into the cell. It could be on either side. In this case, we're moving them out of the cell. And all it does is, down through here at different places, we'll have little areas where this can kind of go inside. And if there's a ball on top of the hill, how do you get it to go down the hill?
Roll it.
Just roll it. Does that require any effort on your part?
Just like in this.
No, no effort at all, right? So no energy is required. So we'll just take this first little ball, we'll let it roll down the hill, so we're going to an area from high concentration to an area of low concentration. This thing here is called the concentration gradient, which is just the cell membrane. And what we're trying to do is make things at equilibrium on both sides. What's equilibrium mean? Anybody know what equilibrium means? If something's equal, what is it?
The same.
The same on both sides. That's what equilibrium is. So we want to make sure there's the same amount on both sides. That's how we're moving from high concentration to low concentration. So this little guy will kind of come down to where it gets through here, and then it will enter the cell membrane, or out of the cell membrane. Then the next one will kind of come down and flow down the concentration gradient and enter there, and then the third and final one will also come down the concentration gradient and go in there, and that's how it gets out of the cell. From high concentration to low concentration, once again, this requires no energy. Okay? No energy at all. Now, there are a whole bunch of different types of passive transport. The one we talk about the most, and probably is kind of the most important to us, is something called osmosis. Okay? Just like Osmosis Jones. And what this is passive transport, so we're moving from high concentration to low concentration, but this is just the movement of water. Okay, so osmosis is the movement of water. Now, passive transport, which I'll notify as PT, will also be called diffusion. So if you see diffusion, things are diffusing across the cell membrane. It's the same thing as passive transport. So osmosis is diffusion of water, just movement is all it means. Okay, so osmosis is the movement of water. Now, when we talk about water or solutions of things or any type of movement, there are three different situations in which a cell can be in a different state. And they are, the first one is isotonic. Okay? Isotonic's like baby bear's porridge. What was baby bear's porridge?
Just right.
It was just right. So isotonic means it's at equilibrium, get the same amount on both sides. Should be it. Okay. An isotonic solution would look something like this. So we've got the same amount outside of the cell as we do inside of the cell. So once again, baby bear's porridge, just right. Everybody with me so far? Okay, the other two types of solution. Next one is hypertonic. Hypertonic has an R in it. Okay. Which means there's too much outside of the cell, and since it has an R in it, it causes the cell to shrink. Okay? So hypertonic with an R means it shrinks. There's too much stuff outside, not enough stuff inside. So a solution or a cell more outside than in. Okay, hyper, shrink, more outside than in. The other one is hypotonic. Hypotonic has an O in it, which helps us remember that it swells up. Oh, it gets big. Okay, so it has too much where? Inside. Very good. Too much inside. And this, of course, causes it to swell. It will eventually burst if it gets too big. Too much air in the balloon, too much water in the balloon, eventually it's going to pop. Okay, and it would look more like that. And that's usually talking about cells and water, too much salt, not enough salt, that causes cells to shrink and not to shrink. If you eat a lot of salt, what does your body automatically, what does it want? If you eat something salty, what do you want?
Water.
You want something to drink. It's because your cells are too saturated, so they're too shriveled up. You need some of that water to flush out some of the salt out of your cell to get your cells back to being isotonic. Eventually, you drink enough water. Are you thirsty anymore? No, you're not. Okay, because you have reached equilibrium within your cells and salt. Okay, so that's the major type of diffusion or passive transport is osmosis. There's a couple more though that we need to talk about. This one is called facilitated diffusion. I don't know how that's typed, but that's kind of cool. facilitated diffusion. When you facilitate something, what's that mean? If you're a facilitator.
Fill it up.
What?
Fill it up.
No. Facilitate means you help with, you oversee, you kind of do whatever needs to be done to help things across. This is what facilitated diffusion is. Some molecules are too big to just diffuse across the cell membrane on their own, so they have to use something to help them move across. And what it uses is carrier protein. So facilitated diffusion uses carrier proteins. To help move larger molecules. Molecules. Okay, so carrier proteins help you move larger molecules. All right, that moves us on to the next type of transport. So if passive, would anybody have any clue what the other type of transport would be? It's the opposite of passive. Progressive? It's close. Active. Active transport. So if passive transport doesn't use energy, obviously active transport does what? Uses energy. Very good. And what is the energy molecule that's used? It's 3 letters. May know? ATP, adenosine triphosphate. That is the energy molecule that is used. Now, we talked about with passive transport going from high to low. Active transport probably means what? Low to high. Very good. So what we essentially do is we take the ball that we rolled down the hill, we attach an engine to it in the form of ATP, and we go right up the concentration gradient. So it's just the opposite. To get back up the hill, you've got to have some sort of force. That's why it's called active transport, because it has energy requirements on it. Okay? An example of active transport, that's sodium, that's potassium, sodium-potassium pump. Removes 3 sodiums from the cell. And inputs 2 potassiums. And it's like a revolving door. The ATP spins that thing around to get rid of the sodium and put in the potassium. Channel proteins are used here. Anything that has a little bit of energy. And next, is endocytosis and exocytosis. If you had to guess, which one's in, which one's out?
Endocytosis.
Yes, endo is in, and exo is out. Now, endo and exocytosis uses those things you saw in your cell diagrams the other day. Uses vesicles, and those are just things that kind of come in and engulf whatever's needed to go either in or out of the cell and help move it out. So endo and exocytosis uses vesicles to help move stuff in and out. And the very last two things that you need to note. Pinocytosis is cell drinking. So taking in liquid to the cell. And therefore, phagocytosis means what?
Dehydrated.
What?
Dehydrated.
No. What else do you do when you drink? You go to dinner, you have something to drink, you have something to what? Eat. Okay? And it's just taking in stuff, molecules, nutrients, whatever it may be, it takes it in to help it. Okay? That's 7.3. That's the active passive transport moving stuff across the cell membrane.